Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to learn about a new subtopic 1.2 called mole concept. So the concept of mole is super important in learning chemistry. You need to master interconventions involving mole. To recall your prior knowledge on this, mole is a name of specific number of things. Let's say we have a carton of 24 things. A mole is a way bigger number, which is 6.02 10 to the power of 23 things. So mole is not an abbreviation of molecules. So it can be any particles, atom or molecules or ions. So number of particles can be determined by multiplying it with the number we mentioned earlier called Avogadro constant, 6.02 10 power of 23. So once you times this number of mole with these Avogadro constants, it depends on the questions. If the questions ask for atoms, then the unit gonna be per atoms. If the questions ask for molecule, then the unit gonna be per molecule. From number of mole, we can also find the mass of compound by multiplying it with molar mass or vice versa. So this molar mass can be found in periodic table with the unit of gram per mole. A very quick example regarding number of particles and molar mass. So to start with, we're going to use an example of 1 mole of water. So we could see we have 2 hydrogen atoms in here and also 1 oxygen atoms. In terms of molecule, we got only 1 water molecule. As for number of particles, these numbers need to be multiplied with the Avogadro constants of 6.02 10 power of 23. So if we talk about number of H2O molecules, since we have only 1 water molecule, so this one need to be multiplied with Avogadro constant. And then in terms of oxygen atom, we know that we got only 1 oxygen atom, so this 1 oxygen atom gonna times with Na, the 6.02 10 power of 23. Even though the number is the same, but they are talking about different things. One is molecules, another one is oxygen atoms. Then, if we are talking about hydrogen atoms, we could see we have 2 hydrogen atoms, means we need to times these Avogadro constants with 2, because it's in terms of hydrogens. And lastly, if we are talking about the whole number of atoms, so we have 2 hydrogen, 1 oxygen, means altogether 3. These 3 atoms gonna times it with the Avogadro constant. While for molar mass, with the unit of gram per mole, we know that each hydrogen atom got 1 gram per mole, while oxygen atom got 16 gram per mole. If you are asked to find the molecular mass of water, then you need to just sum everything up. So we have 2 hydrogen and 1 oxygen. So simply 2 times 1 and plus 16. And lastly, the molecular mass of water gonna be 18 gram per mole. Next, we're going to learn about chemical formula. Chemical formula is basically shorthand way of expressing the types of atoms and the number of atoms that are present in a substance. There are 2 types of formula, empirical and molecular. Empirical formula is the simplified formula where it's all about the ratio of different types of atoms in compound. While the molecular formula, which is regular formula I would say, tells us how many atoms of each element are actually in the compound. The question usually involves hydrocarbon that contain carbon and hydrogen only, or hydrocarbon that contain heteroatoms, means you have carbon, hydrogens, and other atoms as well. So for this example that we are going to do, involve nitrogen. So from this statement, it states that compound A contains carbon, hydrogen, and nitrogen without knowing how many atoms of each element. So this is going to be the first clue. You know your formula must contain C, H, and N. Next sentence tells you another clue regarding combustion reactions. So this combustion reactions is basically we have this compound A to react with oxygen gas. So from these combustion reactions comes the key numbers that will aid us in determining the formula, which are 9.88 gram of compound A, 2.72 gram of carbon dioxide, and 1.97 gram of water molecule. The first thing you need to do is to write the combustion chemical reactions like these, where you have compound A and oxygen on the left hand side and carbon dioxide and water on the right hand side. And then to extract all the information given like this so that you can clearly see what is going on in here. Don't forget to put an unknown X, Y, and Z at each element in compound A because we didn't know yet how much of them will be there. So we'll proceed with focusing only on your product. So look at your product, find the mass of distinct element first. What is meant by distinct? Look at your product here. We have CO2 and H2O. In CO2 and H2O, we have both oxygen. So let this similar element aside. Focus only on the distinct element, carbon and hydrogen. So what does this mean? You could see both CO2 and H2O got C and H, and then you need to relate it to compound A on the left hand side where it got both carbon and hydrogen as well. So this tells you that the carbon dioxide mass in here will tells you about the mass of carbon in A, while mass of hydrogen gas in water will tell you the mass of hydrogen in compound A. How are you going to find their mass? So we're interested in the element. So our aim is to find how much carbon is there in carbon dioxide. So we'll start with molar mass of ratio carbon to carbon dioxide because we know this carbon is in the carbon dioxide. So we need to put mass of carbon up here divided by mass of carbon dioxide comes from 1 carbon and 2 oxygen. So it will tell you 12 gram per mole of carbon divided by 44 gram per mole of CO2. And then you need to times it to the reference value of carbon dioxide given earlier, which is 2.72 grams. So lastly, you get to know the mass of carbon in compound A is actually 0.7418 grams. Next, for hydrogen, there are 2 hydrogens in water molecules. So in your ratio here, you need to include 2 hydrogen even though you want to get the number is for 1 hydrogen in here. Often students make mistake that they only put 1 in here because here they say mass of H, but little that they know, here we got 2 hydrogens, so they must include these 2 hydrogens. Then times it with 1.97 gram, therefore you'll get 0.2189 grams of hydrogens. Lastly is the nitrogen. Some might think the remaining from carbon and hydrogen will be the mass of nitrogen. This is totally out of context. You cannot simply put an end to this because clearly there are no nitrogen present in both carbon dioxide and H2O. So don't bother to find the mass of oxygen if your compound A got none of them. So we clearly say that we want to know element A compound, so always relate it to compound A. So you already have the mass of carbon, you already have the mass of hydrogen. To get mass of nitrogen, simply subtract mass of carbon and mass of hydrogens from mass of compound A, 9.88. So you're going to get your mass of nitrogen 8.9193 gram. Next step is going to be tabulations of data. Make sure that you have all the 5 components, element, mass, mole, mole ratio, and also simplest mole ratio in your table. So your compound A got 3 elements, carbon, hydrogen, and nitrogen. So you need to add 3 more columns. So the one in here we call row, this one is column. So add 3 more columns. Simply transfer the mass calculated in previous page to your table. Make sure that you include the unit preferably at the first column here to save some space. From the mass, we can find the number of mole for each element. So we're going to divide them with their respective molar mass in gram per mole. So for carbon, we have 0.7418 gram divided by its molar mass of 12 gram per mole. So gram and gram will be cancelled and then left with only mole. So if you don't want to write mole in here, make sure that you include the unit in here. Next, for the mole ratio, look for the smallest number of mole from all three elements. So for carbon, we have 0.06, hydrogen 0.21, and for nitrogen 0.63. So out of these three elements, we're going to say that the smallest number of mole belongs to carbon. So we're going to take this number, all of these mole, to be divided with the smallest number of mole comes from carbon, like this. So from here we got to get the mole ratio. As you know, ratio, there's no unit for ratio. So let's say we assume that this is going to be A, B, and C. You can use your own calculator to calculate this, but I'm going to use only the general letter A, B, and C. Assuming the mole ratio you got here is already a whole number, so you can simply transfer this number to the final row of simplest mole ratio. So the value that we're going to include in our empirical formula is the one from simplest mole ratio. So make sure to write this sentence. Therefore, empirical formula is C, A, H, B, and C. As a reminder, just now we assume we got whole number or closest to whole number with uncertainty of plus minus 0.01. If let's say you get value of 3.5 or 10.3, which is way bigger than 0.01, never round off the value. Instead, multiply with only one factor to the whole row so that they will give you whole number. If you take salt crystals and put it in water, you might notice that the atom becomes smaller with time. We usually say that the salt is dissolving in water to form salt solutions. So if we try to mix and match to their respective definitions, we could say that salt solutions is a homogeneous mixture of two or more substances. And salt as a solute is the substance present in a smaller amount. And lastly, water as solvent going to be substance present in the larger amount. When dealing with solutions, we need to use concentrations measurement. Here is a list of concentrations measurement that you need to know. You need to know the definitions to be able to use the formula correctly. How to define this? By looking at their unit. We will start with molarity, denoted by capital M, with the unit of mole per liter. So the unit suggests that the formula gonna be mole. This mole belongs to the solute divided by. So this divided by, how do we know this is division, not multiplications? By looking at the unit, it suggests per liter. Per means divide. So the volume that we are talking about belongs to the solutions. For the mole and volume to stand as a formula, they somehow require numerator and denominator of 1. Therefore, molarity can be defined as for every 1 mole of solute require 1 liter of solutions. Next, molarity. So molarity denoted by small letter m with unit mole per kg. So this time around we are talking about the mass. The unit for mass is gram or kilogram, but for molarity specifically we use kg. So the unit suggests that the formula gonna be mole again, mole of solute divided by comes from the per kg here, and the mass here belongs to the solvent. Note that not always the denominator belongs to solution. Sometimes there can also be solvent. You have to be careful with this. Again, for this unit to exist, they require numerator and denominator of 1. Therefore, molarity can be defined for every 1 mole of solute require 1 kg of solutions. Moving on to the next concentrations called percentage by mass, denoted by percent and also W over W. So this W belongs to weight. So weight in here we are talking about the mass. Since we are talking about percentage, we will find a ratio. Ratio means divisions happen in here involving the same unit. So lastly, they're not going to have any unit left. But then your ratio must come from the mass as suggested from the name itself, percentage by mass. So you must make sure that you have mass in here, not volume, not mole. Then you need to relate it to the 100%. Please be careful with the mass of solutions. Some questions immediately give you mass of solutions, but some of them can also give you mass of solute and solvent separately. Another formula of percentage gonna involve volume. So you have exactly the same concept as in percentage by mass. The only difference now is the ratio involves volume. So volume of solute, volume of solvent, and volume of solutions. So basically, the denominator must always be the volume of solutions. So please be reminded, for both percentage, they will have only percent at their final answer, no other unit like molarity and also molality. Then we have mole fractions denoted by X. So you need to look at the questions, which mole does they referring to. So the denominator can be either solute or solvent, but for the nominator, they can be either solid or solvent, but the denominator will always be moles of solutions. Make sure to first find the mole, then only you can use this formula. Well, as for mole fractions, no unit needed. Lastly is the density. So density, we have this rho symbol. So densities of solutions has the unit of gram per mil, sometimes gram per liter, depending on the questions. So everything on density usually belongs to solutions. So this gram suggests the mass of solutions, while this mil or liter suggests the volume of solutions. Let's look at the calculations involving concentrations measurement. A student prepared a solution of NaCl by dissolving 1.461 gram of NaCl in a 250 ml volumetric flask. What is the molarity of these solutions? So you need to find the molarity. So you need to first write the formula of molarity, where you have mole of solute divided by volume of solutions. Always write this solute and solutions. And then you need to cross-check the information given with the variables in the formula. So from the statement, you must also identify who's going to be the solute and solvent and also solutions. So solutions is prepared by dissolving 1.461 gram of NaCl in 250 ml volumetric flask. In general, we know solutions is solute dissolved in solvent. So means NaCl being dissolved gonna be the solute, and we're given its mass. So first informations followed by 250 ml volumetric flask. So flask is basically an apparatus, not a solvent. But since solvent is liquid and we know volume of liquid takes up the shape of container, we can assume that this will be our volume of solutions. If the questions didn't say anything dissolved in specific chemicals like ethanol or benzene, so the solvent is usually water. Our formula requires mole of solute instead of mass of solute. Knowing that in the conventions of mass to mole can happen, so you need to first find mole of solute by dividing it with molar mass of NaCl. If you are unsure about the formula, check the unit. We want to keep only the mole and cancel out the gram. So do anything that you can do as long as you get this mole up here. So proceed to this, you're gonna get the number of mole of NaCl is 0.025 mole NaCl. And then we're going to calculate the molarity. So you've got your number of solute, you've got your volume of solution. Make sure your volume of solutions is in liter. At the moment they are milliliters, so you need to divide it by 1000. So basically 1, 2 and 3 gonna be 0.25 liter. So if you don't want to write this formula, you can also use symbol like this. This is for checking purposes only. So substitute the value like this, and lastly molarity of solutions will be 0.1 mole per liter or mole per decimeter cubic, accepted, Or you can also use this capital M. This capital M represent molar. Next, we have molarity. First, you need to write the formula as a checklist, what kind of information together. So we have this mole of solute and also mass of solvent to find. At the moment, you are given solutions containing 8.89 gram glycerol in 75 gram ethanol. Solutions containing, after this word, they must belong to solute, which in this case, the glycerol. So this glycerol will be the solute, followed by in. In here refer to the solvent, which in this case, the ethanol. So if the questions already give you specific chemicals to be the solvent, please use them. Don't assume all solvent is water. Since you are given only the mass of solute, so we're going to repeat the same step as in molarity. We need to first find the number of mole for glycerol. So how do you know the molar mass of glycerol? Look at here, we have C3, 3 times 12, 8H, 8 times 1, 3O, 3 times 16. So they're going to give you 92 gram per mole. So we're going to cancel out this unit gram and gram. This mole will come up here. Then you're going to get mole of 0.0966 mole. And then we're going to proceed to the molarity formula. We already have the mole of solute together with mass of solvent. But please be reminded, your mass of solvent should be in kilogram. At the moment, you only have 75 gram. So for you to get from gram to kilogram, you need to divide it by 1000. 1000 means you're gonna move this decimal point to the front. So 1, 2, and 3. So you're gonna have your mass of solvent equal to 0.075 kilogram. And lastly, your final answer of molarity gonna be 1.29 mole kilogram per kilogram, or you can also write it as molal, or small m belongs to molal as well. So a sample of 0.892 gram of potassium chloride was dissolved in 54.6 gram of water. What is the percentage by mass of KCl in these solutions? So you need to first identify who's going to be the solute, solvent, and solution. So if it states here a sample of, so usually this sample of, after sample of belongs to the solute. So your solute going to be potassium chloride, followed by was dissolved. So obviously solute is dissolved in. After in comes the solvent. So your solvent gonna be water, it states here. Before this, they didn't state anything. Okay, so now you have the information regarding mass of solute and also mass of solvent. So what is the percentage by mass of KCl? Your KCl is equal to the potassium chloride. So in the solution, so you need to take out the formula for percentage by mass. So write the formula. Our percentage by mass should be mass of solute, so you have them, and then divided by mass of solutions. You only have mass of solute and mass of solvent. You don't have the mass of solutions. So in order for you to get this mass of solutions, you must add these two. Then only they can be considered as mass of solutions. And then simply times with 100. So by you can also use this symbol if you don't want to write this, and then substitute the value, and lastly you're gonna get percentage by mass of KCl equal to 1.6%. Don't forget the 1.6% here. If you just leave it as 1.6, they're gonna be mole fractions. A 200 ml of perfume, so everyone knows perfume, right? Contains 28 ml of alcohol. So what is the percentage by volume of the alcohol in these solutions? So perfume itself is the solutions, and then inside the solutions we know we have solute and solvent. So contain alcohol, alcohol gonna be the solute. So the percentage by volume, first you need to take out the formula. So volume of solute, we have volume of solute. Volume of solutions also we have 1. and then simply substitute the value, and lastly you're going to get 14% of alcohol. Very simple. A sample of rubbing alcohol contains 142 gram of isopropyl alcohol and 58 gram of water. So what is the mole fractions of alcohol and water? So this is another example that use a sample of. Just now a sample of belongs to a solute, but then you also need to check the grammar of the sentence because it states contains 1 and 2. So obviously a sample of rubbing alcohol in here belongs to solution. So in your solution you're going to have solute and solvent. So usually the one with the largest mass gonna be the solute because they are very concentrated, and then the water will be the solvent as they are universal solvent. Okay, look carefully. What is the mole fractions? Fractions, not just mole fraction. We got S in here, means they are going to be more than 1 mole fractions. So we're going to find mole fractions of alcohol separate to mole fractions of water. So first thing first, you must always write the formula. So again, we need to check the questions because they ask for fractions. So this nominator, not necessarily the solute, sometimes they can also be solvent. So what is important here, instead of having mass, you need to change it to mole. So you need to do a bit of work in here. So you need to first find the mole of solute and also mole of solvent, then only you can substitute the value into this formula. So let's start one by one. As for mole of solute, you know 142 gram, it already gives you the chemical formula in here. Simply substitute the value, and lastly you're going to get 2.3667 mole of isopropyl alcohol. And then you must also find the mole of solvent. Your solvent now is water. So water, we have H2O. So you have 18 gram per mole. Lastly, your mole of solvent going to be 3.222 mole water. So now the questions wants mole of solutions. So you must add these two to become the denominator for both cases. But then for your moles of solute, you can change it to mole of solvent as well as asked by these questions. So now we're going to substitute. As for mole fractions of solute, the solute becomes the denominator. Simply substitute the value and you're going to get 0.423. So since it's just a fraction, they got no unit. And then we have mole fractions of solvent. Make sure your nominator belongs to this mole of water. And lastly, you'll get 0.577 H2O. So all the examples given in previous pages all belongs to direct questions. For questions that has insufficient data, like they want to find molarity, but information given got nothing to do with the molarity, so you need extra information regarding this. So you need to make some assumptions based on the concentration. So focus on the concentration measurement if you want to do the assumptions. Also, please be reminded, often students make mistakes with this. As long as they do the assumptions, they think that they're gonna ace the questions. But you must be remember that only one assumptions can be made per questions. If let's say you have assumed 1 liter of solutions, in the same questions you cannot use 1 kg of solutions to become the assumptions. You only need to keep one assumptions for a question. And then please keep your answer up to 4 decimal points upon reaching final answer, because if you round off too early, then it will affect your final answer. So sometimes the range will move a little bit far from the desired range. And lastly, if you are still working on the calculations, you must substitute exactly the same number calculated. Okay, please bring it forward, or given in the questions. If the questions write 1.000 gram, then you need to transfer exactly the same 1.000 to the formula. Let's try an example of questions involving assumptions. So a sample of commercial concentrated hydrochloric acid is 11.8 molar HCl. So if you have this molar, they belongs to molarity and has a density of 1.190 gram per mil. Okay, so now these are the informations given, but the questions ask you to calculate percentage by mass, molarity, and mole fractions of the HCl. Just a very quick review about this formula. Mass, unit mass. You don't even have anything about mass in here. Molarity, unit mole, and also mass of solvent. Still, nothing in here can be used to find this directly. And then mole fractions, you want to find the mole. You don't have any information regarding the mole. So it shows that these questions got kinda insufficient data. So what you need to do, you need to take these informations out and try to define them by using formula. So we need to first define this molarity. So molarity is the mole of solute divided by volume of solutions. So we have this value 11.8 mole per liter, followed by the density of solutions given in here is gram per mil. So we have mass of solution divided by volume of solutions. You have this number. So now you must decide which of these two gonna become your assumptions. So when you making assumptions, basically you need to relate it to definitions. Okay, so you know if without this number 11.8, we know that 1 mole of solute require 1 liter of solutions. But at the moment, you got number in here. This 11.8 belongs to mole. Means that you cannot take this mole of solute to become the assumptions. Usually, we'll take the 1 liter to become the assumptions, the denominator. Because by dividing with 1, then you'll get 11.8 mole. So, between these two, usually we take molarity or molality or percentage by mass or percentage by volume or mole fractions. They all comes before density of solutions. We can also use density of solutions, but in certain cases, they are not applicable. Okay, so we have decided to use this molarity of solutions, and then you need to do some assumptions. You want to say that this denominator volume solution equal to 1 liter. For this question, you need to state your assumptions. If you simply substitute this value without mentioning any assumptions made, then everything else will go to a waste. Okay, so by assuming 1 liter, or we write it here as 1000 ml, I will tell you why you need to put this as well. You're gonna get mole of solute equal to 11.8 mole. Okay, now, can we already proceed to percentage by mass or molality or mole fractions? Wait, look at another information given here. Even though you already have one crucial clue regarding mole of solute, look here, for your density of solution, you have exactly the same denominator as in molarity of solutions. So, we can first get some more information from this density of solution. We settle it one by one. So, here, we have unit of mil. Just now, you assume 1 liter, but they are also equivalent to mil. So now, can you get any other information from this density? Yep, because this is per mil. If we change it to 1000, then you can get the mass of solutions. So we simply substitute our assumptions. Okay, just now we say only one assumptions per question. Yes, you can make one assumptions and use it repeatedly. Because you have exactly the same assumptions. This is what it meant by one assumptions, but they can use more than one time. Okay, so you are going to substitute this volume solution 1000, not 1 liter, due to the unit used here. Then you're going to get mass of solution 1190 gram. Okay, so you have mole solute, mass of solutions. What else? Now we'll proceed to mole of solute. Since we have this mole of solute, we can find the informations in here. So now, your mass of solute, we need mass of solute because this percentage by mass require amount of mass given. So now, we have our solute as HCl. So HCl molar mass gonna be H1Cl35.5. So it makes up to 36.5 times with the number of mole. Mole times gram per mole, left with only gram. So you've got your mass of solute. So you have mass of solute, you have mass of solutions. Then you can find the percentage by mass. But then, before you proceed to percentage by mass, you can also find the mass of solvent, because we know solution equal to solute and solvent. So you can simply substitute to get the mass of solvent, rearrange it to be on the left hand side, and lastly you'll get 759.3 grams. Don't bother to calculate these, try to extract information as much as you can. Now we can proceed to the questions being asked. So we can calculate the percentage by mass since we have got this mass of solute, mass of solute, mass of solvent, basically the mass of solutions, and times with 100%. And then once you substitute this value, you're going to get 36.2% of NaCl. Next, we want to find the molarity. So molarity require mole of solute. So we already know our mole of solute gonna be 11.8 mole, and the mass of solvent, just now we have 759.3 grams. Then we are going to change it to kilograms. Lastly, our molarity of solutions is 15.54 mole per kg, or you can also use molar or small letter m. Lastly, you need to find the mole fractions. In order for you to find the mole fractions, you need to first find everything in mole. We only have mole of solute. In order for you to get the mole of solutions, you need to find the mole of solvent. That's why it is important to get the mass of solvent first. Okay, as for these questions, solvent is not stated, means your solvent gonna be water. So our mole of solvent, we know the mass of solvent, and our solvent is water, so we simply substitute the molar mass of water. Lastly, you'll get 42.18 mole. And then you are going to substitute into the formula. We got no mole of solution. What we have is solute plus solvent, which makes up the mole of solution. So simply substitute into the formula like this. And lastly, your mole fractions is 0.2186 without unit. When dealing with solutions, you also need to know a procedure called dilutions. It is used to prepare less concentrated solutions from a more concentrated solutions. So how is this going to look like? We are going to take a small amount of stock solutions in here by using pipette for a more accurate reading, and then transfer it to another volumetric flask. When we use volumetric flask, it is more accurate in terms of its reading because we have this calibration mark. And then how to dilute it? Just like you make juice, you are going to put some water. So the water that we are using in a lab, usually distilled water. So we're gonna pour some in here until it achieves this calibration mark. So therefore, you're going to transform these concentrated solutions to diluted solutions. Calculations involved in dilution procedure will use this formula of M1V1 equal to M2V2, or M initial V initial equal to M final V final. So usually the initial will be the stock solutions and the final going to be the diluted solutions. So if you are given informations in statement or what else, you need to take these informations out and then simply substitute into the formula. You can keep it as mil, no need to change it to liter if they've got exactly the same unit, because we're going to cancel them out. And then lastly, you're going to get these 0.0675 molar as the unit because it states here molarity. That's all for 1.2 mole concept. As for tutorial, you may now attempt for both non-face-to-face and face-to-face questions involving week 1 hour 3, week 2 hour 1, and week 2 hour 2. Thank you.